Hello and thank you for coming to check out this video. In this one I'll be talking about a call that failed while trying to allocate a transcoder. Inside this GitHub repository that I have, this is the file that I'll be looking at today. And there's two different calls in that one which fails and then one that succeeds. First I'm going to show the call failing when trying to allocate the transcoder, and later on, I'll do the call where it actually works. The transcoder was successfully allocated. Before getting into the traces and looking at the call, I first want to mention that a transcoder is a type of media resource, and there's all sorts of different media resources out there, such as music on hold servers, enunciators, media termination points, more often called MTPs. There's conference bridges, and they all do their own different things. Conference bridges obviously help people to have a conference call. Music on hold servers obviously play music on hold for people that get placed on hold either during a transfer or just to actually put them on hold. Enunciators can play ringback when needed, or when you hear something like your call cannot be completed as dialed, an enunciator can play that for you. Transcoders work as translators almost. So if I'm speaking to somebody who speaks French, but I speak English, unless they speak English too, we're not going to really be able to understand each other. They're going to be speaking French, I'm going to be speaking English. We need somebody in the middle to convert my English to French so that they know what I'm saying, and their French to English so that I know what they're saying. Essentially, that's what a transcoder can do. So let's go ahead and fire up this sketchpad. If we have a phone here and they are talking to another phone over here, this guy may basically be like, "Parlez-vous français?" And then this guy is essentially going to say, "Nope." At that point in time, the two of them have realized that they don't speak the same language. We can then pull in an excoder. Really, it's a transcoder. These two will speak English, while these two will speak French. And that's because this transcoder can both speak English and French. If the transcoder can't be allocated, then the call will end up failing because it's just a sort of catastrophic failure. In actuality, we won't be talking about languages, we'll be talking about codecs, whereas on this side, maybe they're doing G729, and over here they're doing G711. Now, the transcoder itself is going to need to be able to speak both G729 and G711 in order to have that conversation between the one phone at G711 and the other phone at G729. Now that we have all of that out of the way, let's go ahead and take a look at this file called important information. That's inside of the archived, the zip file that we have uploaded to the GitHub repository. For the failed call, it lets us know what time that was, and for the successful call, we have the timestamp here as well. Calling party information, called party information, and information about the transcoder also. The first call I'm going to look at is the failed call. There should only be one call in that particular file set. There's going to be a few calls in this file set. Let's go ahead and open up the directory here, and we'll copy out that directory path. Control-C. Then I'll go to the called party number, and I'll highlight that while hitting Control-Shift-F. Then I'll paste this directory into the directory path. We want to put in, like always, dd equals quotations open and quotations closed. We get our hit. I'll mark that as style token 2. Then I'll go to the front and mark this as style token 1. This as well. Now I want to mark this section as my digit analysis. Looking at the time, 21:46:17:781, 21:46:17:781. So we know we got the right call here, plus we only got one hit in the file, so it's the only call to look at. If we scroll down like usual, we're looking for this line here, digit analysis, wait DMPIV response. On this line, we're going to get our CI1 from here. And I'll highlight that with style token 1. Then we're going to search in files for it. And you can see we get 203 hits across 2 different files. Let's go ahead and scroll down to find where CI1 is synced up with CI2, or I guess associated with CI2 is the more proper way to call it. We'll hit that with style token 2. And then I'm going to search for that in all files. We get 170 hits in 2 files. Now already we can see here in the call logs, we can see the call termination value, 47. Let's go back and see if we have that in the other one. We do. Going back to Firefox, you can see I have the Cisco call detail records codes up. Scrolling down and finding number 47 in the call termination cause codes, we can see number 47 is going to be resource unavailable. And what they're talking about is the media resource being unavailable. Whenever there's a cause value 47, you already know that that's going to be a media negotiation issue. What I mean by that is that they didn't agree on a codec or something along those lines. Once we see the cause value 47, immediately we know that we can just jump right into the logs and find where the call ended. Right now, we're looking at, are we looking at CI1 or CI2? We're looking at CI1. It doesn't really matter if you look at CI1 or CI2 here, but I'll go ahead and start on CI1. Let's go find its SIP signaling. We have that here. I'm going to highlight the SIP call ID right here as a style token 1. We're going to find all of those, and let's mark those up. Then we can do, we'll skip the 100 trying, we'll do the 180 ringing. And let's see what we have here. 503 service unavailable. What did I put up here for the 180 ringing? That's actually getting sent to party 1. And then party 1 sends an ACK to the 503 service unavailable. The call ends right there. Let's go ahead and walk down party 2 side of the call. We'll get that SIP signaling. Style token 2. Then we get a 200 OK coming in from party 2. Let's see what's next. Now, CUCM sends an ACK with a content length of 0. Typically, at this point, we would actually see the CUCM send an ACK with some SDP in it, and the content length wouldn't be 0. Actually, if you look at my previous videos, you'll see that there was SDP as the content type, and the content length was more than 0. Right here, we'll go ahead and mark this up and say ACK sent to party 2 with no SDP. And now we see the buy with a cause value 47. Now we'll just put this in here. Sent to party 2. Now I'm at the end of the call, and we see our cause value 47 here. Then we can start walking our way backwards, and this is going to be something similar to what I did in the video where I was showing the CUCM deep dive down in the weeds, and then looking at the voice gateway debugs. We were looking at how the different processes talk to each other. What we're going to do is look at how the different processes talk to each other and walk our way back to when that cause value 47 first started. Now, we know that this is the SIP message being sent out, and we know that this whole stack here, I'll turn off the word wrap, is the SIP message being built. Let's go up a little bit further. You can already see a cause value 47 here. This is what we're going to be tracking down. All of these cause value 47s. Let's turn the word wrap back on just for a moment. We can actually see it here. Now what I want to do is highlight this call dependent call control value, and I'll give that any style token I feel like giving it. But we can see that route list control heard from call dependent call control about the 47. Let's see who told call dependent call control about it. From here we can see matrix control told call dependent call control, which I'm just going to say CDCC, about the connection error. Let's see who told matrix control about any of this. We see a disconnect status coming from connection manager. We see that connection manager was told about the disconnect status from media coordinator. Media coordinator was told about the media connect error indication from media manager. And it looks like media manager was stopping the call here. Media manager was told by media resource manager about the MRM allocate MTP resource error. MTPs, which are media termination points, are different than transcoders, but they're kind of treated the same inside of the call manager service. That's because an MTP can be used, that's because a transcoder can be used as an MTP. An MTP cannot be used as a transcoder, but a transcoder can be used as an MTP. At this point, we can check who told Media Resource Manager about it. And we can see here Media Resource CDPC is telling about the Media Resource Manager allocate MTP resource error. Just above this, we can actually see that there was a codec mismatch. We want to then go ahead and mark that up. So now we're pretty well on the path of what happened here. You may think that this is the codec mismatch that occurred between phone A and phone B. This is actually the codec mismatch that occurred between the phones and the actual transcoder itself. In fact, if we take a look, we can see that this call ID does not match either of the two that we looked at earlier, which ended in 07 and 06. So 06 was for party A, 07 was for party B, 08 is for the transcoder actually. If we go up a little further, we should be able to find out where the negotiation was trying to take place between the codecs for the transcoder and the two parties. I'm going to go ahead and turn off word wrap here. Now we can see the allocate MTP resource request here. You can see the device name and the CI for that device. Now you can see the MTP/transcoder device capabilities, which is 151186, this whole long number here. These capabilities for the transcoder will actually be listed out twice because they have to be listed out for the negotiation that happens between the transcoder and party A, as well as the transcoder and party B. We can see here these are the device capabilities of party A, and these are the device capabilities of party B. What we can see here is that party A and party B could have agreed on the codec 4, which is G711. The problem though is that the transcoder itself didn't have G711. It doesn't have device capability number 4. With that said, we find out that the transcoder cannot match codecs with the two parties. Therefore, the call ends because the transcoder can't be allocated. Let's go back and take a look though as to why party A and party B both support G711, but they couldn't agree on it. To do so, I'm going to go back to my CIs, and I'm going to look for the point where we see the media connect request. Right here, we have a media connect request, but specifically I want to see the one, you can see here, we have media connect request, and another media connect request. Really, I want to go to the one that says wait connect request. That's going to be the state that it's in. I'm going to hit the home button to get back over to the other side of things. Now, if we scroll down just a little bit, we'll see where the different capabilities are being exchanged. The main line that I want to look at here is the pre-check capabilities. I'm going to turn on word wrap here. What we can see is we see region 1 and region 2. That lets us know that both devices are in the RTP region. For party 1, I'll make that style token 1, and for party 2, I'll make that style token 2. We can see the cap count number. Party 1 has 11 different codecs that it supports, whereas party 2 only has one codec that it supports. This is going to be the capability and the packetization time, the P time. That's the number of milliseconds of audio that's going to be put into each packet. You can see each one is put into parentheses. This is the capability or the codec, and this is the P time. Right here we have G711 ULAW, and it's supported both by party 1 and party 2. Now why couldn't they agree to it? Why didn't they agree on it? Why did they say that they needed to have a transcoder? It doesn't say it in plain English, but if you look right here, this one yells out, caps mismatch, so capabilities mismatch. Transcoder required, kbps 8. What does kbps 8 mean? That is telling us that if a phone call is made between two devices within the RTP region, they cannot use a codec that goes above 8 kilobits per second. That means that the region relationship between these two is capped at 8 kbps. So only only G729 calls can be made between these two devices here. And had this party 2 supported G729, the call would have went through. Unfortunately, it only supported G711. That's where the capabilities mismatch came in, because you're going above what you're allowed to use. Let's go ahead and try to get a transcoder in here. Hopefully the transcoder can do the G729 call in the RTP region, and then the G711 call between the other device and itself. In the long run, we already know that the transcoder didn't support G711, but this device supported only G711, and because of that, the transcoder got pulled in, the transcoder allocation failed, therefore the call altogether failed with a cause value of 47, which we now know means resource unavailable by referencing the Call Detail Records Administration Guide. That does it for this one. The next video that I'm going to do is a successful allocation of a transcoder, and we'll take a closer look at how the allocation request is created and how it gets sent over to Media Resource Manager, and then Media Resource Manager identifies the transcoder that's going to be used. But again, I'm ending it here. I'll see you in the next one.